Hello. Today I will be making a new math data structure that stores a mathematical formula. I will begin by talking about what a data structure is. In the simplest way possible, a data structure is an object that stores data to make efficient programs. For this project, I am using two custom data structures. The first one is the Vars data structure. This data structure stores three separate attributes, those being a constant, a substitutable variable, and lastly an exponent. Of course, we have getter and setter methods. Other methods include a solve for x method that simply plugs in a number for x and solves. We also have a toString override method for display purposes. The Vars data structure is used in my Funct data structure. This is a list of vars that also stores signs and variable rules. The Funct data structure uses hash maps and linked lists for efficient storage. In this data structure, we can add vars, add operations, those operations being add, subtract, multiply, divide, power, parentheses, as well as trig functions. We can solve a funct by adding variable rules. Of course, we will have ways to display our values and function for those who need a visual. Here's a diagram to explain what I am doing. Let's quickly review some of the concepts used. Linked lists hold any object that is not a primitive type. We can access any element in the list as long as we have an index ranging from 0 to the amount of elements minus 1. Unlike arrays, the linked list uses singly linked nodes that stores data and stores a reference to the next node. The linked list excels at adding and removing elements, however suffers at retrieving items. This is because unlike an array, we have to traverse through each singly linked node making the process for retrieving O of n, but because singly linked nodes store a data point and a reference, placing items in between certain elements as well as adding to the back of the list is actually O of 1. The array automatically resizes each addition of an object, making this implementation effective at not only adding items but also handles the issues of resizing. A linked list is used to store symbols and vars. For those who are confused, here's a diagram. As we can see, in each node, we hold data and a pointer to the next piece of data. Of course we cannot forget about the greatest data structure ever, the hash map. Hash maps are dictionaries, storing keys and values. The key is how we access those stored values. Each key is unique, meaning two of the exact same keys cannot exist in the same hash map. A hash map utilizes the hash function to mathematically determine the placement of the value in the hash map. Probing is used when two different keys point to that same position on the map. A hash map is important and impactful here because of its efficiency as well as its ease of use. We use this hash map for variable rules. For those who don't understand, here's a diagram. This is my method class called expression. I had to code this for my data structures class. What this method class simply does is convert math operations to postfix form. Then that postfix form is then evaluated. We do this for efficiency reasons. But for this expression method class to work, we need to talk about stacks. Stacks are a data structure where we can only access the most recently added item to the storage. It follows a last in first out design. I will now demonstrate the purpose of the stack in expression. When converting to postfix expression, we use two stacks. One stores operators such as add, subtract, divide, and multiply. The other stack stores, which I will call post stack, stores numbers and operations. All numbers will be pushed into the post stack. Operators are always pushed into the operator stack. If the priority of the next operator has less priority than the previous operator, then we pop everything from the operator stack and push into the post stack. Parentheses are a special case, only having operators popped out if a right parentheses is present. Parentheses are not pushed into the post stack, only in between operators. Even in the parenthesis special case rule, we still worry about all previous rules. And trig functions act the same way as parenthesis, but the trig function is pushed into the post stack. To demonstrate these rules, let's see an example. We are given the function 5 divided by 6 plus 3 plus 4 in parentheses. We start at index 0 in the array. 5 is read and pushed into the post stack, Division is read and pushed into the operator stack. After pushing 6 into the stack, we see our next operator as addition. Addition has a lower priority than division. Therefore pop everything out of operator stack and push into post stack. After this operation, we push addition to the operator stack. We soon reach the parentheses special case. Push left parentheses into the operator stack. Push 3 into post. Push add to operator, and push 4 into post, and lastly we read a right parenthesis. Pop all operators into the post stack within the range from the left parentheses. Because we still have items in the operator stack, we pop everything out. This should be our final postfix conversion. Now let's evaluate this postfix, using a single stack. It's very simple. When we read an operator we perform the operation of the previous 2 numbers and push the evaluation back into the stack. A trig function is a special case where we only care about taking one singular number. Otherwise, if the next item is a number, just push it in the stack. Using the postfix expression we made earlier, we take 5 and 6 and push into the stack. We read division, and perform the operation of the 2 numbers in the stack. Then we push 3 and 4 and add them together. Push 7 to the stack. Lastly, add the last 2 items in the stack, giving us 7.83. The reason why we do this entire process with stacks is primarily because it's very efficient compared to using a brute force method, linearly traversing through the expression. This is what I will be testing for my program. Here is the purpose of the program. Here are my tools for my program. And lastly, here is the plan. Let's go to VS Code. Real quick. If you guys are enjoying learning about data structures and coding, like and subscribe, as it motivates me to push out more videos. Back to my source code. To start, here is my Vars class, coded exactly how I explained it in the slides. Here is my Funct class, an implementation of my Vars class. We use methods to convert our linked lists of vars and expressions to a singular array, in which the array is used to convert and evaluate a postfix expression. This uses variable rules, implemented in the form of a hash table. The var name parameter from the Vars class is used and substituted to evaluate. Here is my expression class. It's pretty long, but follows the same process I demonstrated earlier. And lastly, here are some preset functions I coded. We can test these presets by initializing funct objects to these static methods. Let's test our code.